Alright, by popular request, here's some review from Chapter 5, and, here we go. I've kind of made a mess of my work area today. I want to show you where the formulas are at, so I wanted to grab my sheet here real quick. Okay. So there's only a couple of things that we did in Chapter 5 that you'll be responsible for. There is a chance that it's asking you to do a Poisson or a hypergeometric, and we did not do that, and I don't know why it keeps asking about it, but if it does, just skip on out of there and go on to Chapter 6, okay? Alright, if you are given a distribution like this, and we were writing them vertically, but horizontally is just the same thing, so I have the x's and my probabilities for each one. I know that it's valid because these add up to 100%, and so all's well. When it says e of x is the expected value. Now I want to point this out on your sheet. For expected value, it's also the mean, so it's mu. What we are doing is taking each x times its probability, and we're adding them up. So in this case, I'm going to do 0 times 0.1 plus 1 times 0.3 plus 2 times 0.1 plus 3 times 0.2 plus 4 times 0.3. I'm going to multiply all those together in my calculator and add them all up. That gives me 2.3. What that's telling me is that I am expected I'm expected that most of the time that it will average out that I'll get about 2.3 out of these choices here with these different probabilities. So if they were marbles in a bag, 2.3 would be the one that I would have the most chance of getting. It's my average. Alright, for variance, and I know we don't do variance a lot, but they really love it in here, and for some reason, every time I choose problems with standard deviation, it changes them to variance. So I don't know what to tell you, except let me just show you how that's done. You're going to do this time, variance is sigma squared, so we are just not going to take the square root at the end, and I'll show you that here in a second. We're going to take x squared times its probability, and we're going to add up all of those. X squared times the probability, and add them all together. And then when you get that, subtract mu squared, this guy that you just got. Subtract mu squared. Okay, and that's the whole shindig there. So to find variance, I'm going to do 0 squared times 0.1 plus 1 squared times 0.3 plus 2 squared times 0.1 plus 3 squared times 0.2 plus 4 squared times 0.3, and I do all of that first, which 0.4 plus 918 plus 7.3. That is the first piece of this formula. Shoom, I added all those together. Now I'm going to subtract mu squared. So I'm going to take 7.3 minus, here's mu, 2.3 squared. So, minus, and I get 2.01. Okay, this is variance. Standard deviation is the square root of that thing that you just did. So this is kind of a 2-for-1, isn't that fantastic? So for standard deviation, I'm just going to take the square root of the variance. So here goes nothing. Yep. Alright, so I get about 1.417, so I'm going to go 1.42. So here's mu, here's sigma squared, here's sigma. Now, this one says find the probability x is greater than 2. Let me scooch that up, sorry. Greater than 2. So greater than 2 is this one and this one. So I add together 0.2 and 0.3 and get 0.5. That's my probability. The probability x is greater than or equal to 4. Funny question, but they keep tossing out all kinds of stuff with these random generators. Greater than or equal to 4 is only this choice, so it's 0.3. I can't add anything together or do anything other than that. Okay? So that's the first kind of problem that should be asked about. The second type involves comparing two things. And so when we were in class together, we were looking at a circus and a new game that they had. So these are kind of like that game to see which one is better. We want to know which one has a higher payout. So what we're going to do is find the expected value of each one. That's all. You use the expected values to find the higher payout. So expected value is x times p of x, adding them together. I'm going to have to do some typing here. 10,000 times 0.5, 50,000 times 0.18, and that gets me 9,200 for this one. The expected value over here, I'm going to take negative 40,000 times 0.45, negative 25,000 times 0.28, and 35,000 times 0.27. And that gets me negative 15,550. So the higher payout, plan A. That one's going to pay more. This one is taking away money. That's a negative payout. So they're taking money from you. Okay? So that's the second thing that you're expected to do in Chapter 5. The next one is to make your own table. And so in this one, if you draw a card with a value 5 or less from a deck of cards, I will pay you $45. If not, you pay me $16. Aces are high in this case, so a value of 5 or less means 5, 4, 3, 2. Okay, so I'm going to set up a table. Either I win and you pay me $45, so I gain it, so it's positive. Oh, I'm sorry, I pay you. You win. Heavens, I'm trying to hurry. Okay, if I lose, I pay you $45. If I win, I get $16. There we go. Now, the probability of me losing is, well, I got to find out all the cards with value 5 or less, so that's 5s, 4s, 3s, and 2s in each suit. So there are 16 out of 52 that are value of 5 or less. And then this one is always the rest of them. Now I know in this case we could add those together and no big deal. But I want you to know that this is always the complement. It's everything else. Okay? Yeah. Well, let's go ahead and find it. 52, 42, 36, 52. Okay. Now, we have expected value to find. We just made our own table. We're going to take x times, x times p of x and find the sum. So I'm going to take negative 45 times 1650 seconds plus 30, 16 times 3650 seconds. And I'm going to add those together, and that's the mu. That's the expected value. 16 out of 52 plus 36 out of 52. That gives me negative 2. Dagnabbit. Who writes with pencils all day? I can't even tolerate it. 2.77. Now I rounded 2 decimal places because we're talking dollars and cents here. So the expected value is, I'm going to be giving money away. That's what that is. I'm expected to lose. So if I play this game 742 times, what do I expect to win or lose? Well, each time I expect to lose $2.72 on average. I'm sometimes going to win and sometimes going to lose. So that's $2,055.34 I'm expecting to lose. Okay? And a negative means lose, and they do tell you that in the problem, so you don't have to just remember on your own. Alright, the last thing we did in chapter 5 was binomial probabilities. So a researcher studies the color preferences of car buyers. 40% of them prefer blue. If 14 car buyers are randomly selected, we're going to find two things. The probability exactly 10 of them like blue. So here's the thing. There's a percentage going on. You either prefer blue or you don't, is what we're looking at. So it's binomial. It doesn't say binomial, you just need to know percentages mean it's not a mean, so it's a proportion. Okay? Separate in your head. It's either a mean or a proportion problem. Always, always, always. Is it a mean or a proportion? This one's a proportion, so this is binomial. So I have 14 of them, and 10 of them like blue. Sorry, I was going to show you where that's at. It's right here. Binomial distribution. That lovely formula that we used. Make sure that you've got that sorted out there. Alright, this is the probability that they do, and there are 10 who do, and the probability that they don't, and there are 4 who don't. Alright, so remember that was under the math menu, and then you went over to PRB to choose that 10, and then we're going to take that times 0.4 to the 10th times 0.6 to the 4th. So I get 0.0136. I like 3 and 4 decimal places. Round to whatever they tell you to. Be very careful on your rounding. You don't want them counting you off for something silly like that, okay? Alright, the probability that 10 or fewer like blue. Well, you know what would be easier to find? Because I'm going to have to find the probability of each and every one. Because I need to make... Essentially what I'm doing is I'm making one of these tables when I'm doing this. But I don't want to make the whole darn thing clear up to 14. What would be easier is to take 1 minus the probability of, since this is 10 or fewer, I need 11, 12, 13, and 14. You remember doing this? Now don't forget your 1 minus at the end, because that'll get us all the ones that are 10 or fewer, but this is more than 10, which will make an easy complement to go find. So let me refresh your memory. We're going to do 1 minus, and what I'm going to do is go plug in 11. So I'm going to do 14. You know what? No, I'm not. I'm going to go back up to the one I just had, and I'm going to change it to 11 and 3. So I changed my exponent to 3. Do you want to see that? It's a bit of a glare in there. Change that to 11, change that to 11, and these decimal places get really, really small. If you would like to just go in and type them and then go and grab each one, I'm going to write them down here for the time being. Because if I were on a test situation, on the test I tried to leave you some space. I think that's what I chose. It's really kind of hard to tell sometimes what I'm choosing. There we go. There's a big glare on there. But I told it to have show work on there so that you could write down these numbers. Now if you want to keep them in your calculator, that's probably for the best. I think I missed this exact answer because I didn't have the rounding down. It's really hard to tell where they're going to round to. Anyway, this is 13. So that was 0.00056 and 14. And that is 1, 2, 3, 4, 5. Okay. So, like I'm saying, I would type that in just so I know where your numbers are coming from. That way if your rounding's off and it counts it wrong, well, that won't be such a tragedy. So I'm going to go back into my calculator and add those together. Ooh, did I put a plus? Did anybody notice? Nope, I did not put a plus. Oh. No, I put it in the wrong spot. Oh, mercy. There it goes. Okay. Plus, it's been a day. Plus this one. And that's it, I believe. 1 minus 0.0039, basically. And that gets me 9961. There's the probability that 10 or fewer like blue. Okay, so I hope that helped. I know chapter 5 was a really, really long time ago. And I know that you've all kind of waited till the very last second to do all of this studying, but here we are. Some things that you might want to note on here. Probability of E or F. This one right here, that's a good one to know. And we're doing independent, we're not doing dependent. Conditional, that was important to know. Combinations and permutations, remember this is place in a position and this is making a committee. Okay, we didn't do special ones. Expected value and variance and standard deviation, use the right one. Binomial, cross out Poisson and hypergeometric. We used to teach those back in the day. In chapter 6, everything is about Z. Either it's just plain old normal distribution, Z, just normal distribution there, or we're approximating a binomial if it has a percentage or a proportion, and it says approximate it, then you got to go find mu and sigma and change it 0.5. Okay? And then in chapter 7, okay, in chapter 7 it's all about samples. And so if it says now I have a sample, what's the probability? Then you need to change sigma. If it's a mean, you change sigma by dividing by square root of n. If it's a proportion, you change sigma by taking its square root of pq over n. So see, my z changed. Okay, so it's all about, is it a mean or is it a proportion? Or is it just changing my standard deviation for if it's a normal distribution, then you're just going to divide by square root of n. Okay, so this one was important, this is important, this is important. There we go, the 3 different z's for those, and in chapter 6 this was your z. Okay, alright, I hope you took the time to watch this because I think that was pretty good information for your test tomorrow. Alright, we'll see you later. Hope that helped.